So for this problem, the function is 12 sine pi over 5t plus 42, and the question is how much time would it take for the horse to complete one cycle of motion and returns to its starting height? So what it's really asking for is, well, for this transformation of y equals sine x, how long in seconds will it take for it to complete one cycle? Well, usually sine x takes 2 pi radians to complete, or 360 degrees. So what I'll do is, I'll put some of the information up based on the amplitude change, and also the midline change, which is here as variables a and c, and then I'll adjust the wavelength here with b last. So the first thing I do is I go to my graph and I say, okay, well, the kid on the carousel, the horse, the mid height before it oscillates up and down is at 42 inches. So that's the midline here. And A is moving the seat up to 54 inches and then back down to 30 inches as the horse goes around the carousel, like so. So as the child's going forward on the horse, and the seat is safely between these two values, 54 inches and 30 inches. So I know that when I'm starting at the midline. So the first dot is at time 0. I can certainly place that on the graph. Then the last thing I do is I'm like, okay, I've drawn the midline, I've drawn the amplitude, so I know the child will be safe between here and here. And then I say, okay, well, this is pi over 5. So, well, that's interesting, but since I know that the one cycle is usually 2 pi, I want to know, well, what t can I use to create these intervals of pi? Well, since it's pi over 5, I'll choose my t's to be multiples of 5. So on the left, for my domain, I entered 0, 5, 10, 15, and 20. So then when I plug in, I should get this term to work out to multiples of pi. So here we go. So if I plug in 0, it'll be 12 times 0 plus 42, so it'll be 42. If I plug in 5, well, now I have 12 times sine of pi. It's 5 pi over 5, which is 1, plus 42. So, oh yes, then I'll have, well, let's see. Then I'll have, well, sine of pi is 0, so I'll be back at 42. And also at 10 seconds, if I plug in for 10, then I'd have 10 pi over 5. Well, that's 2 pi. So I'll have 12 sine 2 pi plus 42. Well, I all know that sine, every pi, it's crossing the x-axis. So now I can mark off 1, 2, 3, 4, 5 seconds. 1, 2, 3, 4, 5 seconds. And I know that, well, no matter how the saddle is traveling, the horse is traveling at these 5-second intervals, every 5 seconds, the child will be back to the resting height of of 42 inches. So then I know that, well, based on the shape of the sine wave, I can kind of draw it like so. That's the quick sketch of one cycle. And here's the parent function sine x. I know that between 0 and pi, sine is positive, and we have a positive 12. And I know that after pi, after 5 seconds, between 5 and 7, it's in the downward arc of the cycle, and then one cycle is completed after 10 seconds riding the carousel.